Before we start talking more specifically about the details of the Earth, let's consider the Earth's place in space. Our Sun is the center of our solar system. In fact, it makes up more than 99.8% of the mass of our entire solar system. On that scale, the Sun is huge, and the Earth is quite small. But check this out. This figure shows the Milky Way galaxy, with the Sun shown as just one pretty average star of over 200 billion stars. Further, the Milky Way is also simply one of hundreds of billions of galaxies in the universe. Wow! At that scale, the Sun is incredibly, incredibly small. This is why I'm not an astronomer. It's all too big and vast for me. If we scaled down the universe and used 1 inch for the distance from the Earth to the Sun, which is about 93 million miles, it would still be 4.5 miles at that scale from the Earth to the nearest star, and 150,000 miles at that same scale from the Earth to the next nearest galaxy. Wow, wow, wow. Let's go back to our solar system. It's huge, but at least it's of a scale that is a bit easier to comprehend. Notably, this diagram is an old version of Figure 1.6 from your text. What's wrong with this picture? Did you find the error? There should only be 8 planets, not 9. Pluto should not be listed here as a planet. Pluto was kicked out of the Planet Club. After decades of finding more and more planet-like bodies in the outer solar system, astronomers finally came up with a formal definition of a planet in 2006. And to join the Planet Club, so to speak, a celestial body must meet all 3 of the following criteria. It must orbit the Sun, have sufficient mass to assume a hydrostatic equilibrium. That essentially means it must be nearly round. It must have cleared the neighborhood around its orbit. That means it must be gravitationally dominant, big enough that its gravitational pull pulls in nearby objects, thus clearing the neighborhood. Pluto did not meet this 3rd criteria. It has not cleared its neighborhood. It's not big enough. Thus, now Pluto is considered a special type of dwarf planet called a Plutoid. I just like this old figure as it shows the distance from the Earth to the Sun. 93 million miles. So clearly this diagram is not really drawn to scale, but it's still informative. Here's the current figure. Notice that all the planets in the solar system revolve in a counterclockwise, when viewed from above, elliptical orbit. Additionally, all of their orbits are basically along the same plane. I highly encourage you to take a minute to focus on 2 concepts, perhaps even review them in your textbook. First, the elliptical orbit of the Earth. It's not circular. And also how the 4 inner and outer planets are different from one another. First, let's look at the Earth's elliptical orbit. Ellipses don't have 1 center, rather they have 2 foci. The Sun is at one of the foci of the Earth's elliptical orbit. Look carefully at the image. When is the Earth closest to the Sun? What month of the year? January. We're closest to the Sun in January. When is the Earth farthest from the Sun? What month? July. We're farthest from the Sun in July. Now let's consider the seasons and get one thing straight right now. The distance from the Earth to the Sun is not what causes the seasons. Say that to yourself several times and relook at the diagram. A huge percentage of adults in the United States thinks that the distance from the Sun is what determines the seasons. Not true. Notably, I can almost guarantee that I will ask this question on exam 1 and perhaps even the final exam. So be sure you master that concept. Next, consider how the 4 inner planets differ from the 4 outer planets in our solar system. I summarized it here, but you can also review this in more detail in your textbook. Basically, the 4 inner planets, which we call the terrestrial planets, are smaller and denser, they rotate more slowly, and they are less oblate, or more spherical. That's all compared to the 4 outer planets, which are larger, less dense, they rotate faster, and they're more oblate. Why is it that these large, low-density, fast-moving planets are more oblate? Well, it's directly related to their density and their rotational speed. See if you can figure that out.